Okay, we're going to look at graphing rational expressions, and we're going to start off just with a pretty basic rational expression. We're going to start off with the 1 over x, and we're going to see what that looks like when we graph it. When we graph it, we probably want to find a few points and see what the shape of this is. And usually when we're finding some points, we try to find the zeros. It's going to be a little hard for me to find the zeros of this one, considering I can't actually sub in a 0 for x. So instead, I'm going to just plot a few other points. So I'm going to sub in some points for x, and I'm going to write a chart over here, but really I'm just going to kind of do it in my head as I go because it's not that hard of a expression. So if I sub in 1, so I'm subbing in 1 for x, then 1 over 1 is 1, so I'm going to get 1 for y. If I sub in 2 for x, I would get 1/2. So 2 would give me 1/2. 3 for x, I'd get 1/3, so I'm getting closer to the 0. 4 for x, I would get 1/4, 1/5, 1/6, 1/100th, 1/1,000,000th. So I keep getting closer to 0, but I don't actually hit it. So I'm going to have it going like that. This happens also on the negative side. If I sub in -1 for x, I get -1. If I sub in -2, I get -1/2. So I get this negative other way. Damn it. Okay. This -1/2 like that. -3 would give me -1/3. -4 would give me -1/4. And again, -100 would give me -1/100th. So I would get really close to 0, but not hit it. When you get close to something as you're going to infinity, you follow a line as you're going to infinity, that is called a horizontal asymptote. So horizontal asymptotes you can actually cross. The definition is just that you get close to them as you're going to infinity or negative infinity. So horizontal asymptote in this case is going to be my x-axis. So it's going to be my line y equals 0. So we're going to draw asymptote with a dotted line to kind of show that it's there. So I'm going to draw a dotted line right under and over top y equals 0 because it's hard to see it if I drew it exactly on it. But that would be my horizontal asymptote. Let's see what's happening if I sub in as I get closer and closer to this 0. I subbed in 1 and -1. I'm going to sub in 1/2. If I sub in 1/2, then I'm going to get 1 over 1/2. And we know when we divide fractions, we flip and multiply. So 1 times 2, so 2. So if I sub in 1/2, I get 2. If I sub in 1/3, then I should probably get 3 and 4. And I'm going to keep going up. Again, I can't actually sub in 0, so I can't actually get this point, but it's going to follow that axis. So again, I'm going to have an asymptote. Vertical asymptotes it can't cross. Vertical asymptotes, again, it should follow, and the same thing would happen if I sub in -1/2, I get -2. -1/3, I get -3. So it's going to keep going down. So I have a vertical asymptote at x equals 0 on the y-axis. Vertical asymptotes it can't cross, and vertical asymptotes are very related to my range. Since x equals 0 is my vertical asymptote, that's what it can't cross. They're related to my domain. My domain, which is my x's, would be -infinity to 0 and 0 to infinity, using parentheses since it can't actually equal 0. Since it doesn't cross my horizontal asymptote, I'm going to say my horizontal asymptote, especially in rational functions, is related to my range. So again, I'm going to have -infinity to 0 and 0 to infinity. So this is a standard graph of 1 over x. Standard graph of 1 over x has asymptotes at the axes, and basically is in the top right following the asymptote and bottom left following the asymptotes.